today we are going to add another type of way that we can factor. Okay, so today we're going to look at how we factor 4 terms, and we are going to do factoring by grouping. Okay, so like I just said, this is what we do when there are 4 terms. So factoring by grouping works when we have 4 terms. So when we were looking at factoring out a GCF, that worked for any amount of terms. Okay, we could do that no matter what. And while that works all the time for any number of terms as long as there is a GCF, factoring by grouping does not work all the time. It's something that we can only look at when we are looking at 4 terms. So let's say we are given the polynomial 3n to the third minus 12n squared plus 2n minus 8. Okay, so we have 4 things. 1, 2, 3, 4. The first thing that we are going to do is we are going to split this in half. Well, that's good news, right? Hopefully you all know that half of 4 is 2. So we want 2 terms one way and 2 terms the other. Now, when you cut this in half, make sure you're including that sign with the 2 because that's telling us if it's positive or negative. So we have a 3n to the third minus 12n squared. And we have a 2n minus 8. Okay, our second step is going to be to factor out the GCF of each of these. So good news on this one, that's exactly what we did yesterday. So we're just repeating what we did yesterday. Okay, so over here on the left-hand side, I'm going to ask myself what goes into 3 that will also go into 12. Oh, that's a 3. Do they both have the variable? Yes, they do. And we said that we would always take the smaller exponent. So the smaller exponent is 2. So we will factor out a 3n squared. Okay, so when we divide that out, we'll be left with an n minus 4. Okay, then we're going to do that same thing over here on the right-hand side. Okay, so what goes into 2 that will also go into 8? We can pull out a 2. Do they both have the n? No, they do not, so we can't pull out a variable at all. So we'll get 2 times n minus 4. Now, hopefully you're kind of like, oh, wait, that n minus 4 I see show up twice, right? We see that n minus 4 here and here. It's really important that that happens. If we don't see this same binomial, we either did something wrong or it's not a problem that we can factor by grouping. So it's really important that we see this common binomial. Okay, once we do that and we have that common binomial, our next step is going to be to rewrite this as 2 binomials. And the way that we are going to do that is we are going to take the 2 GCFs that we pulled out in front. Oops. Okay, and we're just going to set them next together. They're not like terms, so I can't actually add them. So I'm just going to put a 3n squared and a positive 2. Okay, my other binomial is just going to be this common one that I have of n minus 4. Okay, and this is going to be our factored answer. Now, hopefully when we look at this, we go, now wait a minute, this looks just like the problems we saw in our last unit where we were distributing twice. And we really just we went backwards of distributing twice, right? Because if we were to multiply this back out, we would multiply this 3n squared times both the n minus 4. And that's what's happening right here, right? 3n squared times n, 3n squared minus 4. And then we would multiply the 2 times both of them, which is what we have happening over here. Okay, and when we distribute it out, we would get these 4 terms, which gives us the original polynomial that we started with. So all we're doing today is doing reverse of that double distributing, multiplying a binomial times a binomial. Okay, we're just doing that backwards. So let's look at another one. Let's say we have w to the third minus 2w squared plus 3w minus 6. Okay, now we don't have to write all these words in between. So when I go to cut this in half, if you visually want to see those written further apart with some distance in between, that's fine. But most of my students are fine just drawing that line and just putting their eyes on the left-hand side. Okay, so when we look over here, right, there's really a 1 here. So what goes into 1, that will also go into 2, right, just 1. Then do they both have the variable? Yes. So what exponent, what term are we going to pull out there? We should be pulling out w squared, right, because we're taking the smaller exponent. Okay, so when we divide that out, we'll be left with w squared times what? We should have w minus 2. Okay, then we're going to look over here on the right-hand side. So we need to find our GCF of 3w and our GCF of 6. So what's going to be our GCF for the right-hand side? Right, we should pick 3 because they don't both have the variable, so we can't pull a variable out with it. So once we pick that 3, we're going to divide it out. Okay, and we should notice, exact same situation as above, this w minus 2 and w minus 2, those both match, which again has to happen. If that doesn't happen, we either did something wrong or it wasn't a problem that we could actually factor by grouping. Okay, then for our final answer, we are going to take the 2 GCFs. Okay, and we're going to put those together. So that's a w squared with a positive 3. And a w minus 2. So that will be our final answer, w squared plus 3 and a w minus 2. Now, just understand that it would be totally fine, right? The order of multiplication doesn't matter. So this binomial could be in front. So we could have w minus 2 times w squared plus 3, and that would be representing the exact same thing. So if you have a different binomial in front than someone else, or if you're looking at a multiple choice answer and your binomials are in a different order, that's totally fine because the order of multiplication is allowed to change. Okay, so let's look at another one. Let's say we have 12y to the third plus 4y squared minus 9y minus 3. And if we want to factor this by grouping, right, it's 1, 2, 3, 4 terms. So the first thing we're going to do is split this in half. Okay, so on the left-hand side, we want something that will go into 12y to the third and 4y squared. What will our GCF be? We should pull out a 4y squared because 4 will go into 12 and 4, and the smaller exponent is 2, which will leave us with the 4y squared times 3y plus 1, right? 4 divided by 4 is 1, and the y's cancel out. Now, we need to be a little bit more careful over here on the right-hand side. So if we look at this 9 and 3, and we say, okay, there's a GCF of 3, if we start dividing this out, that's going to leave us with a negative 3y minus 1. And these two binomials won't match if we leave that as a negative 3y minus 1. So the key here is that whenever our leading number is negative, so our leading number of the second half, when this is negative, we are going to factor out a negative. Okay, so you'll find your GCF just like normal. So what goes into 9 that also goes into 3 is 3. But because this 9 is negative and it's the leading one, we're just going to go ahead and throw a negative on that 3 as well. Okay, so now when we divide, a negative 9 divided by a negative 3 is a positive 3y. And a negative 3 divided by a negative 3 is a positive 1, which is what we needed to happen because now we have our matching binomials. So we can take our 2 GCFs, which is now a 4y squared and a negative 3. and a 3y plus 1. Okay, so last problem we're going to take a look at here. Let's say we have 14y to the third minus 8y squared minus 7y plus 4. Okay, so we have 4 terms, which is good news. We're set up for grouping. So we'll split this in half. Okay, so on the left-hand side, we want to pull out a GCF. Okay, so we're deciding what goes into 14 that will also go into 8. Okay, and we should be pulling out a 2. They both have the y, so the smaller exponent. So we'll pull out a 2y squared. Okay, so when we divide that out, that will give us a 7y minus 4, right? Those y's cancel out. So 8 divided by 2 is 4, and the y's cancel out. Okay, now if we look over here on the right-hand side, okay, we want to find a GCF that goes into 7 that will also go into 4. Well, there's not really anything, but remember, when there's nothing, we're really going to pull out a GCF of a 1. Now, we just looked at this in the last problem. When this first one is negative, what do we need to make sure we do to this 1? We should make this a negative 1 because that leading number is negative. So now we'll pull out a GCF of negative 1. So negative 7 divided by negative 1 is a positive 7. And a positive 4 divided by a negative 4 is a negative, or by a negative 1 is a negative 4. What would our final answer look like for this problem? Right, if we're taking our GCFs, we should have a 2y squared minus 1 and a 7y minus 4.